In this video, you should be able to describe and define projectile motion. So let's get right into it. What is considered a projectile? So being able to identify whether or not something is undergoing projectile motion is really important because it immediately will narrow you down to a certain set of equations and an understanding of what's happening. So even though this lesson will probably seem kind of basic and there isn't a lot of numbers involved in it, it's very general. It's really important that you get a strong grasp on what projectile is and what projectile motion is all about. So here we go. A projectile is an object, it can be any object, upon which the only force acting on it is gravity. Okay, so I just list 3 examples, but really the sky is the limit. An object dropped from rest is a projectile. So let's say you hold, I don't know, a hunk of Play-Doh in your hand and you let it fall out of your hand and fall to the ground. That is considered a projectile because as that hunk of clay or Play-Doh or whatever it is falls to the ground, the only force acting on it is gravity. Okay, because something I probably should have written in here is we assume no air resistance. Okay, we in this course we really will not deal with air resistance. So it's something that it's so small and so negligible that we really don't do many calculations considering air resistance. Okay, so an object from rest is a projectile. An object that is thrown vertically upwards. Okay, let's say you take the Play-Doh and you just throw it up, and you watch it fly in the sky and then come back down. That is a projectile because the only force acting on that hunk of clay after it's left your hand is the force of gravity. Let's say you throw a football or a baseball or any ball to a friend. Once that ball leaves your hand and is now flying through the air towards your friend, it is considered a projectile because the only force acting on it is gravity. Okay, so it's pretty actually simple when you really start to think about that. It's just, is the only force acting on this gravity? If it is, then it's a projectile. Okay. And the other beauty of projectile motion is that free body diagrams are super simple because a free body diagram looks at all the forces that are interacting with this object. And well, since there's only one force, there's only one thing you need to draw on it, and it's always going to look like this. A free body diagram of a projectile, basically here is the object right here, and here is the only force acting on it, F grab, or the force of gravity, okay? And that is going to be pulling it down, all right? So this was a misconception I brought up, I believe, when we were talking about one-dimensional motion, and I'm going to bring it up again. The only force acting on a projectile is gravity, so it doesn't matter if it's flying up, down, right, or left. The only force acting on a projectile will be gravity, and basically, people have a hard time wrapping their mind around this idea that, oh, I just threw a ball to my friend. There must be some force in like the horizontal direction that's causing the ball to keep moving horizontally. Forces don't cause motion, they cause accelerations. And remember, the difference between like velocity and acceleration is an acceleration is a change in the velocity. So unless a force acts upon an object, there's going to be no change in its velocity. So again, a projectile, only force acting upon is gravity. I know I sound like a broken record here, but just really want to try to hammer that in, okay? So many projectiles not only undergo vertical motion, but also undergo horizontal motion. So this will kind of tie into what we've been doing before, where we are combining vectors, okay? So we're going to have components that are in the horizontal direction, and we're going to have components that are in the vertical direction, and we need to kind of break those babies down to look at what's happening, okay? So in projectile motion, there's going to be horizontal and vertical motion going on. And we mentioned in lesson 3, we were dealing with riverboat problems, perpendicular components of motion are independent of each other. They have really no interaction with each other. They are completely independent. So what the horizontal component does can in no way, shape, or form affect the vertical component, and vice versa. The vertical component cannot affect the horizontal component. So they have to be discussed separately. You have to look at the x and the y components separately. So here we have a cannon, okay, cannon right here, and basically you'll notice there's like all these dots all over the place. We're looking at 3 paths of which a cannonball could go. this would be like the cannon, the blue ones right here, would be like the cannonball just rolled out of the cannon and fell down. It wasn't even shot. It just dropped out of the cannon and fell down. This is the path that it would take. And again, it would just fall to the earth, right? You'll notice there is no horizontal motion, okay? There's no movement in the x direction. It just falls straight down, okay? This path here, the middle one, that path there is kind of like what a typical cannonball would look like, right? There is a horizontal component, like you can clearly see it stretches some distance, right? We'll call it x. Stretches some distance, but there also is a vertical component, right? There's some y piece to it, okay? And this is what typical projectile motion looks like. The force of gravity pulls it down, all right? Let's say I went into outer space and I shot a cannon. What would it look like? Well, that's this path right here. If there was no gravity, the cannonball would just keep on going forever, horizontally. There would be nothing, no force to pull it down, to ever slow it down, to stop it, okay? So again, there's a lot of text here, but the presence of gravity does not affect the horizontal motion of a projectile. The force of gravity acts only downward and can't alter the horizontal motion. It has no role in the horizontal motion. And that's because perpendicular components of motion are independent of each other. So projectiles travel with a constant horizontal velocity. So this is, for me anyway, when I was taking physics, this was a hard concept for me to get across. If, and I'm just making this up, let's say this cannonball is shot out with a velocity in the x direction of 100 meters per second. Okay, let's say it's really fast. So it's going 100 meters per second. It doesn't matter if there's no gravity or if there is gravity, it's always going to be going 100 meters per second. Gravity cannot slow that x component down at all, okay? And that is what this last piece is saying, that the gravity cannot slow down the horizontal component of the velocity. It will constantly stay at 100 meters per second. Now in the y direction, it can do some things, but in the x direction, it's not going to slow that piece down. And we'll get more into that later on, but just kind of keep that in mind. That blew my mind, I guess you could say, when I was first learning this. So what about non-horizontal projectiles? Okay, like ones you would shoot up into the air. Okay, so like a cannon is aimed upward instead of just straight across and shot at an angle to the horizontal from a cliff. The cannonball would have a parabolic trajectory. Okay, and basically that kind of like looks something like, and I'm not a real good artist, but something like that. Okay, that's kind of curved. All right, and actually there's a lot of symmetry to projectile motion, and that's going to be a way that we can actually solve problems, is due to that symmetry. That's like the time it takes for it to go from here to here is the same amount of time it takes from here to here. Okay, so it's like the paths are equal. Right? The downward force of gravity would act upon the cannonball to cause a downward acceleration through the entire flight. Okay, so starting right here, all the way through the entire flight, even when the cannonball is going up, gravity is actually still pulling it down. Okay? And again, the presence of gravity does not affect the horizontal motion of the projectile. In summary, and there's a lot of stuff here, so I apologize. Again, a projectile is any object upon which the only force is gravity. Projectiles travel with a parabolic trajectory due to the influence of gravity. There are no horizontal forces acting upon projectiles. So thus there is no horizontal acceleration. The acceleration in the horizontal direction is always going to be 0. The horizontal velocity of a projectile is constant, so it never changes, which goes really well with this. If there's no acceleration, how can the velocity change? Remember, acceleration means a change in velocity. The vertical acceleration caused by gravity is 9.8 meters per second squared down. Okay, 9.8 meters per second squared down. That's the vertical acceleration piece. So the vertical velocity, or the stuff in the y direction of a projectile, changes by 9.8 meters per second each second. That's the very definition of what acceleration means. So again, the horizontal motion is independent of the vertical motion because they are two different vectors. They're perpendicular to each other. That takes care of this video. I'll see you guys in the next video.